All right, guys, I'm going to get started. So welcome to Exploratory Data Analysis in Python. It's more commonly referred to as just EDA. If you want to follow along with my code, just type in this link below. It will take you to a Google Doc with a link to this slideshow, a Google Colab, Jupyter Notebook, so we can follow along with the code, as well as the data set I use in case you want to play around with the code on your own. And yeah, so basically, what is EDA? It's the process of analyzing and understanding your data before you work with it, to look at different patterns and outliers to determine what you want to do with your data. So it's commonly used before building machine learning models or just any type of data analysis that you want to do. So the basic steps of EDA is to find and handle missing values and outliers. And you also want to summarize data with data visualization. It will show you a lot of patterns in the data. And you want to observe correlations between variables. This is particularly helpful for predictive machine learning models to see which variables can predict other variables. And just detect overall patterns is the main goal. Okay, so if you use this link here, Technica EDA, and you go to the Google file, you can see this. You don't have to follow along, you can just look here, but. So a lot of the libraries used for data analysis in Python is pandas, numpy, seaborn. When you think data analysis in Python, these are usually the libraries that you will use. So just to remind you, we're gonna remove and impute missing values. We're gonna remove outliers, the strong outliers. We're gonna summarize data with data visualization and observe correlations between different variables. So to load a data set into Python, you just do this here. And we're just gonna call our file df. So if you do the head function and the tail function, that lets you see just the top few and bottom few entries in your data set. And this is a great way to see what variables you're dealing with at the top here. Just get an idea of what you'll be analyzing through your EDA. Describing is just a simple way to get the mean and the quantiles and the maximum of all your numeric variables. So not your categorical, like your discipline and years since PhD. Oh, by the way, we're working with a data set where we're going to analyze what discipline, what your rank is, and how much you've studied, and your sex, and which ways those determine your salary, like for a professor. This shape tells you how many data points you have. So in this data set, we have 403 different data points and 6 variables describing each of them. So the first step is to find missing values. To do this, we do this function here. If sometimes in data sets there are missing values just through errors in the data set, sometimes they don't, but sometimes they do. So here we see that there's empty variables in the year since PhD column, the years of service, and the sex column. So if we try to analyze our data when we have empty values, it will not end well. So we need to take care of this. So to figure out which points are empty for each variable, we're going to assign it to this variable empty data and use the is not a number function to just sort out which values in that column are empty. And here, by finding the shape of that variable, we see that there's only one value for the years since PhD column. If we print our empty data, we see this, there's no value here for the year since PhD. So to handle missing values, there's 2 options. You can either just delete it, or you can impute a new value based on the overall variable's mean or median. So since years since PhD is a numeric variable, it will be very easy to look at its mean and median and impute a new value for this empty value. So here I'm just looking at the years since PhD mean and median. And now we're looking at a box plot for it. This is how we're using the seaborn library in Python to print a box plot. And since mean is very affected by outliers, we don't want to use the mean to impute a new variable when when there's outliers. So since PhD has no outliers, the outliers, in case you don't know, would be dots on above this or below this line, but there's no outliers. So it's safe to use the mean to impute this new value. So now we're just assigning the current variable column to this old variable, and we're describing it here. Now we're reassigning the original value in the original data set to this new median. By doing this function, we're filling this new value with, the mean previously of the entire variable. And when we describe this, we see that the mean doesn't change because we're just imputing the mean for a new variable, but the standard deviation changes. So imputing that new variable changed our overall statistics a little bit. Now we're just overwriting the original year since PhD column. And now when we do this function we did before to see which variables are empty, we see that there's no more empty variables for the year since PhD, but we still have empty variables for the years of service and the sex variables. So years of service is also a numeric variable, so it's very easy to determine a new value based on the mean or the median. So that's what we're doing here. Same process. I'm not going to go through it again, except now we have outliers. So we don't want to use the mean to make this new variable because the mean will be affected by these outliers. So instead, we're going to use the median. So same whole process, just here's another way you can make a histogram in Python. And we see that there is an outlier here around 100. So we're going to use the median. Now the only one that's empty is the sex variable. The sex variable is not a numeric, so we can't determine the mean or mean easily. So simply, we can also just delete an empty data point. So this function here will allow you to delete one entry of that variable. And now we see we don't have any more empty variables. So now the next step of EDA is to deal with outliers. We did see that the years of service does have an outlier, as we saw in the histogram here. That's a great, easy way to detect an outlier in Python, just by data visualization. So to remove an outlier, this function here basically filters out any values for years of service that is over 80. Or you could do over 60 or over 90, whatever, just to get rid of this data point that we saw here. And now we see that the outlier is gone. Now we're just looking at all of the other numeric values. So salary, we see that someone has a salary of around $1 million. So that's a strong outlier. So we are going to remove that as well, same process. And now we see that it is gone. So we looked through all the numeric values and we got rid of all the outliers and all empty variables. So now we're just going to go through some data visualization with Python just to look at the overall pattern. So if we want to compare salary and sex, male or female, we can look at it this way. We see that there's a lot of males who make a lot more than females here in this data set. And also we can look at rank. So their rank as a professor versus their salary, this kind of makes sense. The main professors make a lot more than the other ones. So let's dive deeper into these correlations between the variables. Like I said, this is really helpful for if you want to build a machine learning model, which variables do I want to use to determine the target variable, which in this case would be the salary. So this correlation function just shows you the basic correlations between all the numeric variables. We see that they're all very high. So that means that all of these years since PhD and years of service will be very good predictors for the salary. And you can also do scatter plots to determine the correlation. We see there's a slight positive correlation between these two variables, and this has a much stronger correlation. Pair plot is a really cool function. When you have a lot of variables, these are very large, but we only have 3 numeric variables here. So this just shows correlations between all variables all around. So yeah, we see that years since PhD would be a great predictor of years of service and vice versa. So we analyzed the numeric variables, which is pretty easy. But now let's look at the categorical variables, like the rank and the discipline and the sex. This unique function shows you all the different entries available for that variable. And this value counts function will show you how many in your data set are each value. All right, and then this function here, the group by functions are really good for determining the mean and standard deviation and the simple statistics of a variable correlating to your target variable, which here is salary. So here we have the different statistics for male and female and their salary values. So we see the mean for the male is a lot higher than the female. And then this is a graph as well that you can do in Python. Yeah, just comparing multiple values at once, male or female, and their salaries right next to each other. Yeah, the male is a lot higher here because there are a lot more males in the data set, but yeah. Same thing here, male, female, and their years of service. And yeah, basically that completes the EDA basically. We handled all the missing values. We summarized the data with data visualization. We got rid of the outliers and observed all the correlations between the variables. So yeah, I hope you enjoyed. If you have any questions, let me know. And if you save that link at the top, you can save all the material, all the code, the data set as well. So you can play around with it and apply that code to other data sets as well. So, all right, thanks guys. That's it.